Can you realize that that you and I and all of us have actually begun the exploration of another world? Come with us. Our knowledge of the cosmos is an ever-growing search with new theories emerging daily and older myths demystified. But we have more definitive ways of understanding the universe thanks to telescopes and space probes such as the Voyagers feeding us new information from the outer reaches of space. So when an important space probes like Voyager sends never-before-seen data indicating new discoveries, it changes everything. But what has Voyager just discovered? And what does it mean for us here on Earth? Join us as we explore how Voyager just entered deep space and sent back a terrifying message to scientists. The Voyager missions have been an integral part of space exploration for over 45 years, giving us some of the very first and most important looks at the true state of our solar system. But these missions were never meant to last this long. When the initial plans for the probe were laid out, born out of pure accidental discovery, the decision to send out probes in the 1970s resulted when Michael Minovich discovered that a spacecraft could piggyback on the velocity of a planet and slingshot further out into the solar system. This would be made possible by a rare geometric alignment to the outer planets that only happens once every 2 centuries. Using planetary gravitation and velocity, it was suddenly possible to reach outer planets such as Neptune much faster, as fast as 12 years rather than 30.
While Voyager 2 launched first on August 21,
1977, Voyager 1 reached the edge of the solar system first, taking a much quicker route despite launching 2 weeks after its twin, where the trip to its current position just outside our solar system was indeed a perilous one. Voyager 1
was the first to reach Jupiter 2 years after launch on March 5,
1979, and Voyager 2 wasn't far behind, reaching the gas giant 4 months later. In July of the same year, using several onboard equipment, both probes took the very first close-up pictures of Jupiter, giving us a glimpse of the famous red spot as well as mapping the Earth-sized hurricanes that plague the planet's surface. We also got data that showed hints of water on Europa, pictures of active volcanoes on Io, and discovered the largest natural satellite in the solar system, Ganymede. But Jupiter was just a pit stop on Voyager's journey, and soon enough, both probes made the trip to Cetus, with Voyager 1 reaching first in November of 1980 and Voyager 2 almost a year later in August of 1981. The visit to Saturn gave scientists a better understanding of Saturn's 10-hour days, and a much more accurate measure of the planet's wind speeds, which could reach up to 110 fastest of any planet in the solar system. While Voyager 2 did an Omega flyby, Voyager 1 gave us a closer look at the nitrogenous atmosphere of the planet moon Titan, as well as discovered the new spectacular moons that orbit the planet. The Saturn was the last planet both probes would observe together. As a decision was made to separate both probes, Voyager 1 took an ecliptic turn heading straight for the heliosphere, while Voyager 2 carried on to 2 other planets. As planned, by August of 1989, Voyager 2 had made it to Neptune, flying just 30 miles over the planet's north pole. The flyby revealed the coolest planetary surface in the solar system, with temperatures reaching -400 degrees Fahrenheit, but data sent back by Voyager 2 revealed the Neptune wasn't as inactive as scientists had previously believed, and the surface was filled with Earth-sized storms and fast-moving clouds. But while the Dyson Neptune was indeed revealing, it left the question of how such a planet with barely any solar energy reaching it could form or maintain such dynamic weather. However, answering that question would be left to future probes. Voyager 2 left the blue icy planet, making its way to the opposite edge of our solar system. By December of 2024, data received from Voyager 1 suggested that the probes had reached the part of our solar system called the termination shock. This is a region in space where solar winds originating from our sun slowed in speed from traveling at millions of miles per hour. to barely 25,000 miles per hour. Although this might still seem incredibly fast, it pales in comparison to much faster interstellar speeds. This reduction in solar speeds is a result of external interstellar pressure from cosmic rays traveling through our galaxy. But the termination shock simply marked the beginning of the edge of our solar system. Voyager was yet to cross the threshold. Voyager 1 was the first of both probes to cross the edge of the heliosphere, a milestone it made in August of 2012. The heliosphere is an invisible bubble of charged solar particles exerted by the Sun on the solar system. And just like other invisible forces such as gravity, the heliosphere's magnetic field protects every planet behind it from violent streaks of cosmic radiation that filled the universe. Scientists made this crossover discovery upon analysis of data from Voyager 1 during a unique solar eruption known